For most of human history, we believed we were the center of everything. The Earth sat still. The sun, the moon, and the stars revolved around us, fixed to a series of perfect crystal spheres turning forever in the dark. That was the universe, small, closed, personal, and then, slowly, over centuries, that picture began to crack. Not all at once, not by accident, but through a long, stubborn line of people who refused to accept what the sky seemed to be telling them. This is the story of how humans figured out the actual size of the universe. And the answer turned out to be far stranger and far larger than anyone could have imagined. Around 2,000 years ago, the most influential model of the cosmos was finalized by a Greek-Egyptian astronomer named Ptolemy. In his model, the Earth was at the center. The moon orbited Earth. So did the sun. So did the planets. So did the stars, all fixed to enormous turning spheres just beyond our world. And for the next 1,000 years, almost no one seriously questioned it. It matched what people saw. It matched their philosophy. It matched their religion. The universe, as far as anyone could prove, was a small, ordered place. And we were at its heart. Then came Nicolaus Copernicus. In 1543, just before his death, he published a book proposing something almost unthinkable. The Earth was not at the center. The sun was. And our planet was just one of several worlds quietly circling around it. It was, in its time, a quietly dangerous idea, but it changed nothing immediately. The book was largely ignored. Many treated it as a mathematical trick, not a description of reality. What it did do was leave a small, persistent doubt in the back of every astronomer's mind. A possibility, a door slightly open. Then someone walked through that door. Just over 6 decades later, in 1609, an Italian named Galileo Galilei built one of the earliest astronomical telescopes, a device originally invented for ship captains. He pointed it at the sky, and what he saw shattered the old model in months. He saw mountains on the moon, not a perfect celestial sphere. He saw that the sun had spots, not a flawless ball of fire. He saw the phases of Venus, proof that Venus orbits the sun, not Earth. And most extraordinary of all, he saw 4 small points of light moving around Jupiter, night after night. They were moons, orbiting another planet, which meant, finally, irrefutably, that not everything in the universe orbited Earth. Copernicus had been right. A few generations later, Isaac Newton would explain why. With a single set of equations, Newton showed that the same force that pulled an apple to the ground also held the moon in orbit around the Earth and held the Earth in orbit around the sun. Gravity. For the first time, the heavens and the Earth were ruled by the same physics. The universe was no longer divided between an ordinary world below and a perfect realm above. It was one connected system, one physical reality, but it was still, in most minds, finite, limited, tame. That was the next thing to fall. For centuries, astronomers had been observing fuzzy patches of light in the sky. They called them nebulae, clouds. Most assumed these were clouds of gas and dust within our own Milky Way galaxy. A few suspected otherwise. They wondered if these fuzzy patches might be entirely separate galaxies, distant island universes lying far beyond the Milky Way. For a long time, there was simply no way to know. And then, in 1924, an astronomer at the Mount Wilson Observatory in California changed everything. His name was Edwin Hubble. Using one of the largest telescopes ever built, Hubble identified a special kind of pulsing star, a Cepheid variable, inside the so-called Andromeda Nebula. The brightness pattern of that star let him calculate for the first time how far away it was. The answer was almost too much to process. Andromeda was not in our galaxy. It was nearly 1 million light-years away by his initial estimate. And we now know the true distance is around 2.5 million. It was an entire galaxy of its own, with hundreds of billions of stars, just like the Milky Way. And it was not alone. In the years that followed, Hubble realized something even stranger. Almost every distant galaxy he measured was moving away from us. The farther it was, the faster it was moving. The universe was not static, it was expanding. Which meant, if you played the expansion backward, there had to be a moment, a beginning, when everything was incredibly compressed in a single point. A point that suddenly began to grow. We now call that moment the Big Bang. And it happened roughly 13.8 billion years ago. In a single century, the universe had gone from a small, orderly place at the center of everything to a vast, expanding, ancient, unfinished system that we are merely one tiny part of. And we are still discovering how large it is. With instruments like the Hubble Space Telescope and now the James Webb Space Telescope, we have seen galaxies whose light left them more than 13 billion years ago, almost the entire history of the universe ago. Some of those galaxies are bigger and more developed than our models said they should be at such an early age. The universe, it turns out, may have started building structure faster than we ever realized. And the part of it we can see, the observable universe, is now estimated to be about 93 billion light-years across. Not 13 billion, 93. Because while the light from the most distant galaxies has been traveling toward us for 13 billion years, space itself has been expanding the entire time, pushing those galaxies even farther away. What we see when we look out into the universe is, in the most literal sense, a story. The story of light that left a very long time ago. We started this story believing the Earth was the center of everything. 500 years later, we know it is one planet among billions, orbiting one star among trillions, in one galaxy among possibly 2 trillion, in an observable universe that may itself be only a tiny fragment of something larger we still cannot see. And we figured all of this out with patience. With glass lenses, dim photographic plates, chalk on blackboards, and decades of looking. Not because the universe wanted to be understood, but because we wanted to understand.